Okay, I guess let's get started. So aloha and welcome to iTeach808, Empowering Hawaii's Teachers in Technology Conference, sponsored by the Augustine Educational Foundation and Sacred Hearts Academy Honolulu. My name is David Ninomiya, and I'll be facilitating this session. We're so honored to have Michael Fricano join us today and share his experience through a 45-minute presentation named VR and AR Creation with CoSpaces Edu. Please be aware that we'll be recording this session. If you don't like to be recorded, you may consider turning off your camera during the session or reviewing the recording afterwards. The recording will be made available on YouTube and shared on iTeach808's website a week after this event. So without further ado, I'll turn it over to Michael.
All right, thank you so much for the introduction. I appreciate it. Good morning, everyone. My name is Michael Fricano II, and I'm excuse me, I'm a K6 design and technology teacher at Iolani School, and I co-teach a design and technology class for all kindergarten through sixth graders at Iolani School. And for this presentation, I'm going to be sharing about what's one of my my number one top tool for VR and AR creation, but it's also a great tool for teaching students how to code. And we're talking about how the tool works and some of the projects that I lead with my students. I've been using CoSpaces Edu since probably since day one of their release 5 or 6 years ago, and it's grown a lot, and it's a really powerful creation tool for students. I'm also what they call a CoSpaces guru ambassador. I've been using CoSpaces a long time, and I love sharing about CoSpaces. I've got a whole website dedicated to all the projects that I've developed, and I've taught with student samples and things like that. Feel free. This is the link to my session website here, and you can jump to that link now if you like. I'll put it in the chat, actually, make it easier for you guys. And on this website is the presentation. Oh, maybe I should turn it into a link. Sorry. The presentation's embedded there along with a bunch of links, and then it's part of my bigger website, my larger teacher resource website that focuses on all things AR, VR in the classroom. So feel free to check out all the other resources that are there. But if you go to that link there, it should take you to a screen that looks like this. And what the presentation I'm showing you today is embedded right at the top here. So feel free to follow along with me there, as well as a bunch of resources further down. Refresh this, and then some information about how to get started with CoSpaces. I'll talk about that a little later. Now, of course, up front, I want to be, honest. I want to be, full disclosure. This is I guess what I like to call a freemium tool. There is a free version of it, like what is typical with other, ed tech related tools. And then there is what they call a pro version, which gives you more features and access to other stuff. So I want to be upfront and honest about that at the beginning. I don't want to show you all these awesome things you can do and then hit you with what you got to pay for it at the end. Okay, so there is a free basic version of this, and at CoSpaces it's a web-based tool, but there's also an app, and you could use it across pretty much any device. But with the free basic version, there's classroom management built into it. So there's a back-end classroom management tool, very similar to like Google Classroom or Seesaw or those other things, where you can set up a CoSpaces class and you can pull your students into that CoSpaces class and then assign them projects and access their work and things like that. So the free basic tool gives you limited access to those tools, as you can see in the list here. And then if it's a tool that you want to invest in and that you're really interested in using with your students, there's what they call CoSpaces Pro, which is a paid annual license to this, and you pay by student feet. And I've kind of highlighted some of the things that come with the Pro version. So of course you get access to everything that's in CoSpaces. There's co-teacher support. So it's a really great tool. Like I like to tell teachers, don't think of it as a tool that only you can use in your class that you have to pay for. It's something that your school could pay for if that's an option, and then multiple teachers could tap into the tool and use it in various ways with the same students across different classrooms and subject areas. There's co-teacher support built into it, so that you can take it. That's more than one teacher can take advantage of the same pro license that you'd have to purchase. And there's this ability to remix spaces, which is basically a version of copying other people's projects and then making changes to it or adjustments to it to turn it into your own project. One of my favorite things about CoSpaces is what they call the CoBlocks tool, which is the block and text-based programming language that's built in. So if I'm going to introduce to you guys in a little bit. And with the pro version, you get access to all of the programming aspects of the tool. And then there's a really neat physics engine built into this. You can actually apply real world physics into your projects, and then you use that in various ways. Okay. And this is on slide 5, but just a quick peek into what that cost might look like, depending on how many seats or students you have in your class or your school. So it starts as low as 5 seats for $75 a year, and then depending on how many seats, that the price obviously increases. And then there's also an option to do a custom order depending on the size of your school or your class or things like that. Okay. Let me get into what CoSpaces is. Okay? So it's probably, in my opinion, one of the best creation tools specifically for augmented and virtual reality. But it's just a really great creation tool in general. And what's really great about it is that it's a tool that's accessible across pretty much any device. Right? So if you have laptops, Chromebooks, or computers, there is a web-based version of this. You can go to a website, which I have open here. I have my account open. And this AR VR creation tool works perfectly well inside of a website. You don't need to download or install some heavy application. You don't need high-end computer equipment to run this. It runs really well just in a website itself. But if you have iPads or other tablets or smaller mobile devices in your school, the tool works through a mobile application as well. So again, pretty much any device it works on, and that's really great. There are other tools out there that might work well on this device, but not so well on other devices. But this one works across all devices. And then whatever students create, whatever teachers create, you can explore those projects, you can consume them across all of these devices and more, including VR headsets and things like that. So again, it's great across all devices. The one caveat here is that because it's a web-based tool and it's also application-based, in order to use it, you have to have a consistent internet connection. It's not an offline tool. So you do have to be connected to a school Wi-Fi network in order to run it. Because as you build, it constantly saves into the CoSpaces cloud in order to protect students' work. Like I say, I mentioned I got ahead of myself there. So again, you can create on via browser. This is the home page of CoSpaces, just CoSpaces.io. So pretty much any type of computer it's accessible on, including Chromebooks, and then a tablet app. It's available on iOS and Android. And then the basic rundown of this is it's a drag and drop system, right? So you have a library of 3D objects that you can see here in this GIF, and it's simple drag and drop. So you have a 3-dimensional space that you're working in, and then you use the library of objects and you drag them in to build a 3-dimensional scene. And you can there's lots of options to manipulate those objects, to resize them, to rotate them on their X, Y, and Z axis. And you can see there's a grid on the bottom to help for easy placement where you can snap objects together. And so I've done this as young as 1st and 2nd grade, where I've just used this simple version of it where they're dragging in objects to create a very simple scene. But of course, it can get way more complex than that. You could do some pretty complicated things with this too. And then on top of the built-in 3D model library, there's also options to upload your own media. So you can upload your own pictures into CoSpaces and use 2D images. What's fairly recent is you can now upload videos into a three-dimensional scene. So imagine like, your students are building their dream school, right? And they can pull in a 3D model of a TV, but they can also upload a video and place it on that TV screen. And within this three-dimensional space, it can seem as if you are watching a real video on a TV screen, right? So there's options for uploading your own videos into the space and controlling when and how you want them to play. You can also upload your own sound files. So if you want background music to play, or if you want student voice to be a part of a project, they can record themselves. They can record themselves talking and then pull that sound file into the experience. What's also really cool about the sound option is there's also a built-in recorder in CoSpaces. So you don't need to use some external, external audio recording tool or application. There's a way to do that built in. So the CoSpaces can record audio for you and then save that audio file in your CoSpaces project so that you can use it for different purposes. And then if you're familiar with like Tinkercad or other CAD 3D modeling software that's out there, there are opportunities for students to make their own 3D models in these external tools, and then bring their own 3D model creations into CoSpaces in order to expand upon their 3D model library when they want to build their scene in CoSpaces. So there's opportunities for uploading your own 3D models. And then there's an option to upload your own 360-degree images, so that rather than getting, the computer animated backgrounds, you could, if you're familiar with 360 cameras and creating 360 imagery, you can actually pull in your own 360 image and make that the background of your scene. So I've seen great examples of like schools doing school tours and creating school tours in CoSpaces where the background is like their library, and then they're creating a 3D scene in their school's library, right? Or it's their classroom, and then they're creating introductory tours for community and families and things like that. And then there's some embed options. You can also embed YouTube videos. Your school has access to that. So you could actually find a YouTube video. You can actually see an example of the coding block that controls that YouTube video in the screenshot here. And you just plug that URL into the space there. And in this example, like, when a player clicks or taps on the dog, a YouTube video can pop up in the scene and play. So based on how your audience interacts with the scene, you can program those different aspects into the 3D environment. And then you can also embed website links. So you can, so like when the player clicks on the dog, it'll take them out to a website, right? So it's a great way to get them started in a three-dimensional space and then take them out to external resources. If there's things outside of CoSpaces that you want to use within a project. So there's great opportunities to not only use what's available in CoSpaces, but also to bring in your own media that your students or teachers could create themselves and pull that into a CoSpaces project. And then, once everything's created, said and done, there's great opportunities for sharing, right? And that's always, like, for me, that's always the end goal of a project, is you have a greater audience beyond me and yourself and sometimes even your classmates. So there's opportunities to share this out with families or with the school community or with the wider world. So every CoSpace that's created gets a couple different sharing options. So a CoSpace gets its own unique QR code. So if somebody were to scan that, they could scan the code, and if they have the CoSpaces mobile app on their phone or their tablet, they would be able to access that project. There's also a share code. So in CoSpaces is a place to enter a code to be able to access projects. And then every CoSpace project gets its own unique share link. So they could plug that into a browser, and it would take them right to that project. What's nice about sharing CoSpaces is that, you have to pay to get all the stuff to create, but in order to view a CoSpace, you don't have to have a CoSpaces account. You don't have to pay for CoSpaces. Anybody in the world is free to access a CoSpace project created by someone else, as long as they have one of the shareable options here, right? So we've done lots of projects, at my school where the kids have created and then they've shared the share link, or they've copied down the code and they take that home and invite their family and their friends at home to view their work. And the people at home they don't have to have a CoSpaces account. They don't have to pay for it. It's free to view anybody's CoSpace project as long as it's been shared. And then when you do get a shareable, when you do share it, there's a couple different ways to explore, to consume a CoSpace project. So there's a way to explore in 3D mode. Get ahead here. 3D mode. So if you just have computers at your school, your students can share them with each other or share them with the greater community, and they can be explored on a computer via the website. Here's an example of a space being played on a laptop. This is a roller coaster experience project that my students have worked on in the past. So creating roller coaster experiences in CoSpaces and programming them. So you can explore on a computer. If at home or even in school, if you have mobile devices, tablets, or you're sharing at home and family members have mobile devices, if they download and install the free CoSpaces app and use the share code or the QR code, they can access a CoSpace project. And you can use what's cool about doing it on mobile is you get these movement controls like you can see in this example here. So I can virtually walk around in this 3-dimensional scene that a student has created by using the forward and backward arrows. And then on the right side, that single arrow there on the right side is a jump option. So I can actually jump over things or onto things. So because these are 3-dimensional spaces, we have the ability to move around virtually in these 3-dimensional spaces, whoever our audience is. And then to get a little fancier, you can explore these, anything in CoSpaces can be explored in virtual reality. And you can, put yourself in any type of VR headset and fully immerse yourself in that scene so that it is as if you are the character inside of that 3-dimensional space. And you take on that first person perspective, and you can virtually walk around and explore a scene, a 3-dimensional scene that a student has created. So the very simple version of VR is a mobile device inside of typically a cardboard or plastic headset. That's like the cheapest option. And then the school VR kits are becoming more popular, and there's lots of different versions of this. Class VR is a popular one. Oculus is becoming more popular. I'm sure you maybe heard about that over Christmas. So like one of the most popular Christmas gifts in homes this past holiday. But there's all different kinds of high-end VR headsets, and CoSpaces is accessible via all of them. But that virtual reality experience is the most immersive and engaging way to explore these 3-dimensional scenes. And then there's also opportunities to explore projects in augmented reality. And to just kind of jump back a second. So if you're not familiar with VR and AR, virtual reality, I like to explain it as being able to take my students somewhere else and transport them from their real environment into this virtual space, right? And when they put on a headset, like the examples you see here, they are fully immersed in that experience, right? And they, typically in a headset, you can't really see the real world in front of you. You are, in 360 degrees, viewing and interacting in that 3-dimensional space. Whereas in augmented reality, it's a way to bring things into your real environment, right? So like in the example here, I'm pointing my phone at my dining room table, and that same scene that we see right here, that we viewed on a mobile phone, can be projected onto my dining room table. And now that 3-dimensional scene that a student's created has become part of my real environment. And looking at it through my mobile device, because it's 3-dimensional, excuse me, I can, excuse me, sorry, I can physically walk around my dining room table or a student's desk or the table in my classroom and interact and view this scene from different angles and perspectives. What's kind of cool too is it's really small on my dining room table, but there's an option to scale it up. So I can make it almost room size. And then we could physically walk around in that scene as if it were inside of our classroom. Right. So this is augmented reality where you're pulling in 3D models, three-dimensional scenes, and you're placing them inside your real environment through a mobile device camera. So imagine like this is like a 3D scene at a house, but imagine like models of the solar system, models of cells, right? Being able to have students design those things and then projecting them into their classroom and sharing them with their class and using these resources to study and prepare. And then also through creation, demonstrating their understanding of these standards and these skills. And then one other way to explore this is through a merge cube. So I don't know if you guys are familiar with a merge cube, but a merge cube, it's an augmented reality tool, but it's it's a tangible square, it's a foam block, but it has these AR triggers on them, almost like QR codes. My face is blocking. And so in CoSpaces, we can create projects for this that projects a CoSpaces 3D scene or model onto the cube. And because this cube is real, I can pick up that model and hold it in my hand and manipulate it in the palm of my hand. So I thought I had an example here. Maybe it's a little further ahead. You can get to that a little later. Oh, it is. I'm going to share a project with you that I've done with the merge cube and CoSpaces, and I'll show you an example of what that looks like. But this is another way to explore augmented reality also, but it's an ability to hold these models and creations in your hands. And then also built in, and this is one main reason why I use CoSpaces in my design and technology class, is that there's built-in coding tools. So they're not just dragging, they don't just have to drag in models and place them in a 3D scene. They can also add animations, and they can make their scene interactive through the use of code. Excuse me. There's a couple different ways to code in CoSpaces. There's CoBlocks, which is a block-based programming language. So if you're familiar with Scratch or code.org, there's many different kinds of educational related coding platforms out there, and they're all block-based. Like in the example you see in the picture there, it's a block that represents code that controls or tells the objects in the scene what to do. So rather than having a bunch of penguins stand frozen in a circle, I can use the CoBlocks tool to program them to animate and move in the scene instead. So now I'm creating animation and movement, and I can also code interactive elements. But if you have more advanced students, or if you're working with older students, there is JavaScript and TypeScript. There's opportunities for using JavaScript, and then they just recently added the ability to program in Python. And this tool is in beta; they're still working on it, but there are options for older students, more advanced students, to program. And I've seen some pretty amazing projects from older students who know how to code in JavaScript and Python create like full-blown games in CoSpaces, that are almost on the level of games our kids play on the Xbox or the PlayStation or other gaming systems. And you can do some pretty cool things with this, with code. And then there's I mentioned earlier, there's a built-in physics engine, so you can actually apply physics properties to objects. So when you drag in a 3D object, it's static, right? So wherever you place it in the scene, it stays there, unless you program it to do something, or you can apply physics to it, like gravity, mass, friction, bounciness. And if you do that, then those objects take on physical properties. So if you have an object hovering in the air at the beginning of your scene and you give it physical properties, and when you play that scene, that object will fall to the ground because there is gravity applied to that object. Right. So I've done a really cool project to do with this is having students build a Rube Goldberg machine in CoSpaces, and then learning how to apply physics to get that Rube Goldberg machine to work all the way through, right? So it's like clicking on the block knocks it over, which then causes a domino effect of all these platforms, which in the end pushes a car into a garage, right? So doing these really fancy things to end up doing really simple tasks at the end, but the kids have a lot of fun creating these really complex, Rube Goldberg machines through the use of the physics tools. Okay, so a couple of projects that I've done in the past through different grade levels. Because I see K to 6, we've used CoSpaces as young as first grade. We mainly use it with 2nd through 6th grade though. So one really great project to get students started and familiar with programming in a 3D space is what we call an all about me CoSpace, right? So it's creating a 3-dimensional scene, but also using it to introduce yourself to the rest of the class while learning how to use the tool. And we use a merge cube version of this. So let me open up this sample project, and you can actually click on this link too. It should load up the sample project that I've created in your browser for you. There we go. So once it loads up, I can click play. And so because I'm doing this on a computer, I just get like a 3D version of this, right? And so we see here is a cube, and then each side of the cube is introducing something specific about you. So what we do is at the top is students create a character that most resembles them. So there's a library of different characters in CoSpaces. They choose the one that looks closest to them, and then they can customize the clothing color and the hair color and things like that. And they learn how to place that character on the top, and then they learn how to upload an image into CoSpaces and place it on the front and change the text. And then around the sides, so like one side is what I grew up I want to be. So they type in what they want to be, but then they also have to use a variety of 3D objects to find things that relate to that, that relate to what it is they want to be when they grow up. Like I want to be a teacher, and I've incorporated some animation and movement into my characters, some other objects. And then we introduce them to the coding tool here with the my favorite side. So we have 3 categories, but there's question marks. And so the way this is programmed is if I click on the question mark for animal, the code, I can't see the code, will flip, or not flip, but it'll reveal the answer to that specific category. So there's some very basic program, a very basic program on the back end that's causing that to happen, that the students learn how to code themselves. And so each one is programmed separately to reveal the answer when the object is clicked on. So there's a very basic, very basic programming skills incorporated into one side, and the other side is what they're looking forward to most this year. And just like that side, they type something into the space, and then they're building a small scene there with different 3D models. And then this is using the merge cube. So if you're on a mobile device, you can explore this in augmented reality. I have an example here. I thought I had an example in here for you guys. I don't know what I did with it. I think I lost track of it. Oh shoot! I'll have to find that a little later. Oops, there. I'll just do it. Go back. Sorry, I got myself all mixed up. There we go. Okay. So that's one way. There's a merge cube version of this all about me, and then there's just a basic a basic all about me version. I think I have it. Oh wait, here. Yeah, these are all of my projects that I've done in the past. Here we go. So there's like a very there's a basic version of this. So they're not building on a cube, they're sort of just building in a 3-dimensional space here. They have these different panels. So this is a template that's set up, and then the students learn to customize it, to edit it, change things. And then they learn how to do some coding to flip these favorite categories around to reveal the answers that are on the back, right? But again, it's a 3-dimensional space. You see I'm kind of moving around and viewing it from different perspectives, and they got to learn how to work and move around in the 3D space in order to completely build out their 3D scene here. Now I've got some links here. So if these are things that you're interested in trying out with your students, I pretty much every project I develop in CoSpaces for my students, I have a template for it, right? So this picture here is linked to a template version of this CoSpace, and with a teacher account, you can make a copy of this and then use it with your students. This is like a template version of the project that's simplified and cleaned up, so that you can share it with kids, and then they can just edit it and make changes to it. Okay, another really fun project. So once we do the All About Me, we move into doing a little bit more advanced programming in CoSpaces, and they create a Floor is Lava game, right? So what they learn how to do is create lifted platforms and a track or a path, and then they learn how to program how to combine objects together and how to make those objects do different things, and then this becomes an obstacle course, right? So, and its floor is lava, so if you fall off the platform at any point and onto the ground, then what they learn how to do is reset the player, take away a life, display that life on the screen so they know how many lives they have left, and then start them over again. And with the controls of the keyboard or the controls on a mobile device, they then share these with their classmates and others in our community, and they have to figure out, oh, I lost there. This one's really hard. It's doable. I think I spent like, and then I lost, game over. And then it starts me over again. The object here is to get through the course. You see some platforms are disappearing and reappearing. And then what's cool back here is this is they once they learn the basics, then they're free to kind of take those concepts and apply them in different ways. So like this one over here, he turned into a giant button. So when you jump on this button, it drops down slowly. And then when that button is fully pressed, it reveals a giant platform that you have to quickly run across to get to the other side, right? So they learn the basics of like creating platforms and how to program them to move. And then they take those ideas and make it a more elaborate Floor is Lava game. And that looks virtually impossible. I don't know how that's gonna happen, but yeah. So this is like the next step in our exploration of CoSpaces and how to program. And there's if it's something that you're not comfortable with, you're not really sure like how to get started, CoSpaces has a really great video. This is what I use to teach the students. So they have this YouTube video called Key Applications Games. Sorry. And they break down how to do a basic version of this Floor is Lava step by step. And so what I do is I take this YouTube video and break it into chunks. And each class we're learning one specific element of this game design process, and then they're applying it. And then the next class will watch like another 30-second clip of this video, apply it to their space, and then continue building from there. So there's some really great YouTube videos that CoSpaces has created themselves to help teach these concepts and different elements of how to use CoSpaces in different ways. And these are linked up here in slide 22. So the YouTube video, and then I also have a link to a basic example of this Floor is Lava example. This is what I use to introduce to the students the project. This is my simplified version. So I just have one moving platform. And then I did it a little different. So I display, well, what I teach them is how to display the lives in real time on their screen while they're playing the game. That student took it a different direction after understanding the concept, and would display the lives when you lose it, and then you would go back to the game. And then when you get to the end, they learn how to program like a goal space. So when they get to the end and they've landed on the goal space, it gives them a congratulations message. And then kids can do different things like that. So like one student I had, when they landed at the end, it took them to a different scene that put them in the middle of like a party where all these characters were cheering for them. and they learn how to animate those characters and make it really fun as a way to congratulate them for finishing their game. And then if I fall off, I lose a life and go back to start. Now I'm at 2 lives. And if I keep doing that, I think in my version, I get kicked out. Yeah. So there's a way, like if they lose all their lives, they get kicked out of the game. That's the basics that I teach them. And then some other really fun ones. So what's really cool about CoSpaces too is that there is collaboration built into it. So for most of the projects I lead, they're working in their own space, building their own thing. But there is a way to assign students to groups in CoSpaces and then give that group, each group member, access to the same space. And they can go into that space on their own device in real time and work together at building a 3-dimensional scene in CoSpaces. So there is real-time collaboration available in CoSpaces too, which can be really powerful for different kinds of projects. So one way that I like to introduce this concept of collaborating CoSpaces at the start is doing this collaborative design challenge. So I assign them to like groups of 3 or 4. That team of 3 or 4 gets access to this space that has this big board on it. And what they do is each member of the team picks a challenge off this board, and they work and talk together about how they're going to divide and use the space at the same time. And each team member is working on this challenge on their own, but they're all doing their challenges in the same space, right? So they gotta work together to not build over each other, to not move each other's objects while they're trying to build. So it's a lot of teamwork, a lot of communication built into collaborating, especially when you're working in the same 3-dimensional space with others. So this is one way that I introduce that concept to them, by having them complete as many collaborative design challenges as they possibly can in a certain amount of time. Usually maybe take 1 or 2 class periods to do this. And this is linked up to I think a website that talks a little bit more about the design challenge and how you can get a template of it. So links there on that site. And then of course there's lots of other use cases. I've seen some really cool examples of classes creating vocabulary museums, right? So they build this 3-dimensional room, and the students collaborate and work together in this space to add vocab words that they've learned, along with examples of those vocab words, and they create this constantly changing vocabulary room or museum throughout the school year. And then students can use this to study and things like that. One of my favorite examples is taking novels and literature that students read and recreating the most significant parts of that story in CoSpaces. So like in this example, you see, I think this is Romeo, Romeo and Juliet. So recreating those scenes and turning them into being able to visualize what that might look like after reading. And then students can create their own stories, right? So taking a story they've written, maybe in writer's workshop, and then creating that in CoSpaces and being able to visualize that and turn that into a 3-dimensional scene that they can then interact with. So making their story come to life with the characters and the setting, and they could program animation and interactivity into that. Some fun, great opportunities for creating dioramas. And I've seen some great examples of teachers, reimagining the book reports, right? The typical book reports. So there's those poster board projects. How can we reimagine and recreate those in a 3-dimensional space and turn it into an augmented or virtual reality experience instead of those classic poster boards or book report projects. Creating models in 3D, like you see here in this example, and then just a great tool for introducing and expanding. Oh, sorry, that was my alarm for the 5-minute mark. A way to introduce and expand upon students' coding abilities. So just using CoSpaces to program is another great opportunity. There's a link here that'll take you to the CoSpaces lesson plan page. It has an always expanding library of free to access lesson plans for different grade levels, different subject areas, and then you can also filter by other criteria. And then again, there's some great lesson plans here focused on different types of project ideas and things like that. So lots of good resources here if you're not sure how to get started. And then I'm not going to click into these, but this is slide 25. If you want to explore any other teacher or student made projects, I've got a list of some of my favorites here. You can click into these individually and access them and explore them if you choose. This is a great museum project here. There's a cool egg hunt. A student made a sunken ship scene. One student made a virtual chess game. Right? So playing chess in augmented or virtual reality. An example of a sugar molecule, and then kids creating some fun games like this one's called Whack-A-Nino. I think this is from a summer camp where they learned how to create a whack-a-mole game, and one kid made it based on their summer camp teacher, which they called Whack-A-Nino, and they shared it in the gallery there. And then there's some great examples of how to incorporate math into this. So this one is a fraction seesaw activity. So you're dropping fractions of objects into this seesaw, and you try to balance them out. And so what smaller fractions here make the whole, right? And so some really cool examples of applying math concepts into CoSpaces also. And if you're interested in learning more, there's some really great communities on Facebook. So CoSpaces Edu has their own Facebook community. It's got thousands of teachers in there, and there's lots of sharing happening almost on the daily. So if you're looking for a community around this, feel free. You can click on the Facebook button there, and you can join their community. There's sometimes they have Facebook Lives where teachers are demoing things they've made. There's great networking opportunities. There's always somebody sharing something that they've done. So it's a great place to gather ideas. And so that's one group. And then another group that I actually manage on Facebook is the Virtual and Augmented Reality for Education Facebook group. So we focus more on like the broader aspect of incorporating virtual and augmented reality into the classroom. So feel free to join either of those groups if you're looking to participate in any kind of communities around these topics in education. And then the last slide, I have my contact information there. I'm always willing to answer questions or kind of talk through a project idea with anybody. So feel free to reach out to me there via email. And then if CoSpaces is something that you're really interested in, or you just want to try it without buying it, there is a code there on the left that gives you 30 days and 100 student seats. Right? So I feel like typically in ed tech tools, they might give you like 15 days, or you get like a week to try it. But you can't really do much with that amount of time in CoSpaces. So there's a 30-day trial there. Gives you pro access to everything, including the Merge Cube tools, and you get 100 student seats with that 30-day trial. So if you're looking to just try it out, try one or two projects. You could probably squeeze in one or two projects in 30 days, depending on how often you see your students. And you just set up a CoSpaces teacher account. There's an option in your account settings to apply a trial code, and that'll give you 30 days free access to Pro. That's my trial code. I don't get any kickbacks from that. I'm not making money off of you using my trial code. It's just an opportunity to let other teachers try this out without having to commit to paying for anything. So feel free to use that trial code, and you can share that trial code with anybody else at your school if you're working in a grade level team, or if there's a group of teachers that you work with back at your schools. All right, guys, that is it. I see some things in the chat. I want to jump there and maybe answer some questions. When did CoSpaces come out? Laurel's asking. I want to say it was about 5 or 6 years ago. Actually, what's kind of cool is they came out as just a consumer tool. It was just just an idea of creating AR and VR in a web environment, and the education teachers picked up on it pretty quick, and they kind of pivoted and turned it into an ed tech tool and made it more usable with younger students also. So it's pretty cool how they've evolved since then. Can more than one student work and collaborate with a yes? I'm not sure what the max is. I want to say we've tried like 10 students in a space. It kind of tends to slow down around the 9 or 10 mark. It's just too many things going on in the space for a student's device to handle. So I would say like safely, you could probably have 3 or 4 students working, collaborating in the same space at the same time. And that's usually like the 3 to 4 range is usually a good number for students to be working together in any ways, but you could definitely test the limits on that. How is the learning curve for both teachers and students? You know, I will admit the learning curve, it's easier for students. I mean, this is an environment that, you know, they're kind of familiar with. Like kids play Fortnite and Minecraft and these games where it involves like building and moving around in 3D spaces, and they get it. Like it's so easy for them to pick it up and you know, just start going crazy with it. It's harder for teachers, right? It's a different tool. And depending on your comfort level with ed tech products and programming, there is a bit of a higher learning curve, I think, for educators. But for me, like, you know, I some of the projects that I do, I'm not comfortable with, but I know that my students are capable of doing it, and so I'm just there to kind of guide them. And typically, like what I end up finding is that different students will get really good at doing specific things in CoSpaces, like coding or manipulating objects. And so when another student has a question about that, I point them in the direction of their classmate, as opposed to me trying to figure out that answer. So we kind of, you know, work and help one another. And I try to find the experts in the room to assist with that. I'm answering my, okay, good. Okay, if you guys have any other questions, feel free to email me, or I'm not sure if we can hang out in this space, but I appreciate you guys joining me today, and enjoy the rest of your iTeach808 conference. Thanks, everyone.
Okay, Michael, sorry.
Yeah.
One bit. Okay, so mahalo to Michael Fricano and for everyone's participation. We hope you'll find this session helpful and make some valuable connections. Please help us complete the survey on the iTeach808 website. I'll post a link in the chat.
Thank you.
Survey will also be sent to the email address that you registered with. Please make sure to check your spam folder for any emails from iTeach808Hawaii at gmail.com. You'll be entered to win one of 20 $5 Starbucks gift cards if you complete the survey by February 4th. So thank you for being here today. Feel free to join any other sessions coming up, and have a wonderful day.
Thanks, everyone.
Guess you guys can stick around if you have any more questions.
Thank you.
Thanks, Deborah.